Okay, so very testable. If 15 times the reciprocal of a number is added to the ratio of 9 times the number minus 7 and the number plus 2, the result is 9. What's the number? So you just want to go really slow and start out with something simple like, okay, they're saying what's the number? Well, why don't I call the number, just the number, x. Let the number be x and then go through the rest of the translation. Anyway, so this will be my x every time I read. Then I go through and I read 15 times the reciprocal of a number. Well, the number that we're talking about is x. So I need to translate a number, which is x, but also the reciprocal of it,
1x.
1 over x.
No, 1 over x.
Because, you know, if this is x, x is currently over 1, then the reciprocal would be 1 over x. Okay, so then now I've got a number x, I've got the reciprocal x. I kind of just go from the inside out, and then I got to have 15 times that. Now the reason why I'm looking at all this first is because that's an entire expression before you get to this pausing word. The is kind of makes a pause. So is added to 9 times, so then, alright, so we're going to go 15 times the reciprocal of a number, and then is added to the ratio. Okay, so it's added to something that was already there. It's added to the ratio of 9 times the number. So
9x.
it's going to be a ratio, though. So it'd be 9x minus 7. Oh, that's a whole expression. 9x minus 7. And plus, or no, that's the ratio.
Okay.
The operation that comes first is the one that indicates what the and is going to mean. You know, like when I say, what's the sum of 5 and 2? Then when the word and shows up, it's a plus because I started out by talking about the sum. If I say, what's the difference of 7 and 4? The and becomes a minus sign because I was initiating the discussion by saying the difference.
Okay.
So if I initiate this by saying the ratio is the quotient or the division statement. So I'm going to wait for the word and it's going to be a ratio statement, so that will be my little division symbol. Yeah, so I think that is what we want to do here. So that ratio, reading it slowly, is 9 times the number minus 7. And, because it's the top and the bottom, and the number plus 2. The number plus 2. And then that whole thing we hope is equal to something, otherwise we don't have an equation, and it says the result is 9. So that's when we say the result of all that is 9. Phew. Messy, huh? Let's see if we can make some room here. Let me try. Okay, so I would multiply by the LCD here. Actually, I'll change my color. And I got to multiply it on both sides. So everything on this side is going to be multiplied by the LCD and everything on this side. But the LCD is not one of those pretty ones because it's going to need an x for the one denominator. But then it's also going to need an x plus 2 for the other denominator. And under 9 is just a 1, so that doesn't contribute, but it still does need to have the LCD multiplied on this side. It just doesn't change the denominator. So then, you know, all of this each time. I guess we can do them one at a time. And then all of this. So what do we get? We lose the denominator, and we've got x times 9x, which is going to be 9x squared minus 7x, plus, then this x right here will cancel out with this x right there, and we're just left with this part to multiply by the 15 times 1. So it's going to be 15x plus 30. Does that make sense?
So these are grouped,
Yeah.
pretending there's another, right, there's something right here.
Yeah.
Instead of like 15, it being its own.
Right. I mean, it is. It is, but a second after you think of it that way, you can think of it as like, how do you multiply 15 times a reciprocal of a number? Well, you multiply tops, 15, and multiply bottoms.
15 over X.
So it's really just, 15 over X.
Okay.
Sloppy handwriting, but either way. And so just like the first one, on the first one, when you do this multiplication, this cancels, and there's just the X part to multiply. But I went all the way through. So X squared X. Then 15 plus 30, because it's going to be all of 15 times all of that. Back to this side. So this, I can just distribute 9x, because it's 9 times x times all of that. So just 9x all the way into each. So, whoosh, whoosh.
Hey everybody. Hello.
And what do you get? You get 9x squared. That works out nice, because there's the same amount on both sides now. Plus 18x. Kind of running out of room there. So,
wouldn't that be? Oh, okay.
So you're going to subtract 9x squared from this side, but there's the same amount on that side, so the x squared terms are going to be gone. You're going to
What about
combine this 7x that's negative with the positive 15x, which is going to make 8x there, positive.
Okay.
And then you're going to subtract the 8x from both sides, leaving 10x. And then you still got the 30. Does that make sense?
I'm lost on the when you're distributing the 9. Do you not have a 9x anymore?
I do.
Or did that just turn into?
Let me get back up here, because it's important. Maybe I'm missing something. I don't want to miss anything. But I was thinking of this as 9x distributed times x. So 9x squared.
I understand that.
And then 9x times 2.
But that 9x isn't
18.
brought down to the next part.
Which one?
This 9x.
It is. That's why I had 9x squared.
Oh, so by distributing it, I understand that you got the 9x and you distribute it. But by distributing the 9x into this, you've now created. Now you don't bring down the 9x. You just take that distributed.
Right.
Portion, and then you drop that down. But the 9x that you actually use to distribute does not continue on.
Well, it's been distributed.
It's been distributed.
Yeah, it's been distributed. So when I say equals, what I have left here and what I have left here has absorbed the 9x
Okay.
being multiplied in, making 9x squared, and the 9x being multiplied in, making 18x. So that's why you don't see it again there, because it's in here and it's in here.
I think when I was having a problem was I was just distributing the 9 just straight up, instead of distributing the 9 to 9x and then distributing the 9.
And I was being a little bit lazy with this too, so I'll be honest. Let's go to this. And I'll change a color here. So technically, I probably should have multiplied this together and said this is 9x, and then that's gone.
Right.
And so now I would have more clearly written 9x times x, which is 9x squared, 9x times positive 2, which is positive 18x. Yeah.
Okay.
That's why I made it look ugly, because we're lazy all the time, math. Okay, so then it's just this stuff down here we got to clean up. So like I said, we're going to subtract that over. We're going to get 10x here, and then we're going to divide both sides by 10, and so we're going to get 3. I'll just go to another slide. So kind of sloppy. So the number is 3, and then you just go back and read through it. You're basically reading through it and replacing it. You're saying you've got 15 times the reciprocal of a number. Well, the reciprocal of 3 is 1/3. That's already going to cancel to make 5. Added to the ratio of 9 times the number, that's going to make 27, minus 7, and what was the other one? 2 plus the number?
I think so.
2 more than the number?
Mm-hmm.
So 2 plus 3. Well, let's see, what would this be? This would be 27 minus 7, which is just 20. And then this would be 5. So we've got 20 divided by 5, which is 4, plus, and then this would have canceled, giving us 5 times 1. And then it's the result is 9. Yeah, so the result is 9. There, you checked it out. Anyway. They're fun.